Obviously, you've got a lot of very talented folks on your team, and you all are doing some outstanding work. Can you kind of share with us a little bit of the principles that you've used to put together that team and even get folks to join you? I got to think that might be a challenge, getting the right talent pool in place. Welcome to Emphasis Tech Talks, podcast for business leaders navigating technical challenges to find a competitive advantage to elevate your bottom line. Today's guest is Grant Anderson with Paragon Space Development. Grant, thanks a lot for joining us. Appreciate you taking the time.
Yeah, my pleasure to be here. Looking forward to this.
Yeah, me too. So Grant, you've got quite the exciting background and doing some great things there at Paragon. Why don't you give us the really quick 1-minute description of the kind of work that you do there?
Okay. Well, Paragon does life support in extreme environments. That means that because space is the ultimate extreme environment, that a lot of our business is human spaceflight, keeping humans alive, keeping biological systems alive in space. However, we also do groundwork, protection systems for warfighters, protection systems for different military branches and civilians in different environments, again, where the environment is trying to kill you quickly. And we let you survive during that environment.
Wow, that sounds like some really exciting work. On this channel, we're talking to business leaders and we're talking about technology. Can you tell me a little bit about the technology that you use in those areas and the technologies maybe that you don't use?
Okay. Yes. It's often shown in popular media that space is this high-techy thing, sort of the Star Trek type thing. And in fact, The Martian, if you saw the movie, I always say the most unrealistic thing about Martian, the movie, was how modern the NASA buildings look. Because in reality, adoption of technology in the space world is very tough. It's got to be proven. It's got to work, especially not just all space, but in the world of life support, literally lives are in your hands. So we do any technology that keeps a human alive. So that's usually air revitalization, keeping the humidity down, keeping the CO2 cleaned out, keeping the trace contaminants that we put out. As humans are very dirty when you put them in a small closed can with each other. Actually, we shed hair and skin and we fart, if you pardon the expression, and we have to pee and poop and everything else. Then it's also keeping at the right pressure, of course, keeping, you can't fluctuate the pressure too much. You have to keep the right amount of oxygen, keeping fires from happening, being able to put them out, being able to clean out the environment from that. All that type of things or functions we do requires different technologies. And it also requires different technologies if you want to do it for 3 days or 3 years. And then also the communications part of it. We also do human factors. How do humans see their environment? How do you give them information? How do you feed them information that's useful, that they can act on right away, that's accurate? Making sure that happens. And then finally, keeping everybody at the right temperature, which includes the electronics, which includes the batteries, but it also especially includes the humans. We're very picky. We like to be 70 plus or minus 2 degrees, depending on what you and your spouse want. It's usually on the opposite of those two spectrums. But
exactly.
That's part of it. Awesome.
So, that's quite a broad range. When you mentioned something there that kind of made me think about the testing. And I know even before the podcast, we were talking about the testing some. So give us a little idea of some of the testing that's involved before you can bring new technology into that kind of an environment.
Mm-hmm. Well, first of all, there's 2 types of environments. Those are things that are external to the spacecraft, which is vacuum and high amounts of heat, high amounts of cold, very cold. And then there's internal. And generally what we have is what we call the corners of the box. What's the highest temperature? What's the lowest temperature? What's the inside? What's the most humidity, least humidity you have to do? And we have to be able to test all of that, plus the transportation environment. The getting on a rocket and lighting millions of pounds under something shakes the heck out of you. And you've got to make sure you're not interfering with other things, with your electronic outputs, what we call the EMI, electromagnetic interference. So all of that testing has to be done to what we call qualification levels. Like, in other words, if you're expecting to get X number of dB of acoustic energy, you need to test it to that times, 1.2, 1.3. So you test it above, beyond what you think you're going to get, so it won't break in your environment. And that includes, electronic testing. What's your susceptibility to radiation? What radiation to put out? What type of interferences are in the system? All of that has to be tested. So there's a very strict set of specifications in the space world that say you have to pass all these tests before we'll ever allow you on our spacecraft or on our launch vehicle or anything like that. It's a very tough test regime, very expensive. And so you have a new technology and you need to get over what we call that valley of death of that testing. Finding somebody who wants that badly enough to be able to work with you to get that tested, or have the resources to test it yourself is always the big thing about getting space hardware done.
So how do you manage a team? I mean, this sounds like that would be a huge team to try to get that kind of testing done, in multiple different skill sets and so forth. How do you go about that? What's kind of involved in managing that kind of a project?
Yeah. Well, first of all, what you said is actually kind of why I started this company. It is a multidisciplinary environment. This isn't just building a robot for space, which is what a communication satellite is. So it takes everybody. It takes chemists, biologists, mechanical engineers, electrical engineers, and everybody else. The way we have to do this is to understand where we're trying to go, what tests we have to get through, and planning it out. The old adage, plan the work and work to the plan. And then when you have problems, you got to figure out how to fix it. But making sure that you have those multidisciplinary managers that understand the steps, don't make shortcuts that will then hurt you later down the line. That's all important. And then, of course, the test. Making the test design is really important to us. Too much data is almost as bad as too little data, because what you have is if you have too much data, very often with the number of sensors and they drop out or they mess, you're actually chasing more time wondering what went wrong with your test setup than actually what you're testing. But being able to take that data, reduce that data, and understand that data, and really important is to pick out when that data doesn't make sense or when it deviates from norms. So there's a fair amount of analysis you do up front so you can recognize the issues when you get to the test. Hey, wait, that fan's drawing 20% more energy than we thought. Why is that? That humidity system is supposed to be able to remove X grams of water per minute, and it's only removing half of that. Why? Those types of things are very important. So it's again a fair amount of analysis up front, running the corners of the box and figuring out how your system models in that behavior, and then comparing it to your test results. And I would say one of the things that gets forgotten by the younger engineers up front is, yes, you have to test this. and then one of the, I call it the Iron Man syndrome. I actually have a name for it. If you remember the scene from the original one where he's making the Mark II and he's talking to his computer and they're going to change this and change that. And that's when they make it red and gold. And they says, well, how long until this is going to be done? Well, it'll take 5 hours and 32 minutes, sir. And he goes off to a party and comes back and it's all ready to go and fly. That's not how it happens in the real world.
Right.
So, but you can very often get engineers that think that, well, I finished the drawings a week ago. How come we're not sending this to the customer?
Right. Yeah, absolutely. So, a lot of parallels there to the kind of IT projects that we deal with as well. So, I'm curious, What about agile project methodologies? Is that something that is creeping its way into your world, or you still more on a waterfall kind of project methodology? What's happening there?
Yeah, no, definitely agile. I think is used around our offices multiple times a day. In fact, I know there's a few meetings on my calendar that's agile this or agile that. Um, it's interesting. I'm a very process oriented person. You have to be in my industry, and I always point out that doing things faster doesn't mean skipping steps. It means learning how to do steps faster. If that's in parallel, you can do that. Somebody gets 25% done, they can hand something off so they can be working something while you finish up your stuff. That's one way to make yourself agile. The other one is to keep teams small. If you've ever read Kelly Johnson's book about the Skunk Works, and one of his first tenets was keep the program small, because then people communicate more quickly. Zoom and the COVID industry has been really tough for us people at Innovate because you don't have those little hallway conversations. Hey, Joe, we just failed this test. What do you think's wrong? Oh, well, we'll maybe try this. Go back, try it, and it works. That's the agile environment. The Zoom of, okay, I'm going to write a text, and then, oh, they haven't seen it for 3 hours because they've been on a telecon. So there's that side. The other part of agile is having the communications product, the computer products. There's a lot of parallel working now, whether the equivalent of Google Docs. We can talk about cybersecurity. We can't use Google Docs because we can't trust other people's outside security. But the idea of that collaborative environment, and it's not really good. I can't even say it's ready for prime time yet, in that some of these collaborative environments, I just had an example. I was working on a proposal with a Spanish researcher the other day, and they decided to put it in Google Docs to work with their team. And then they sent it back to me, and it had totally messed up the Microsoft Word formatting, the automatic table of contents, the automatic references to figures and stuff. I spent 4 hours rebuilding a proposal 12 hours before it was due because of that collaborative and software and environment doesn't really work well. So that's an issue with that. These new products are not even that new. The Atlassian products like Jira and stuff like that, being able to work collaboratively, those all help. But I will say my IT professional, my director of MIS, and I have a standard joke that we never use more than 20% of the power put in front of us with these screens and keyboards and stuff. You'd be surprised how many new outs from college, I teach them how to run Word because they've learned how to use it like a glorified typewriter.
Right. Yeah. Yeah. Wow. So you mentioned cybersecurity. I just imagine that's got to be a very big factor in what you do, and you obviously spoke to some of that already. But can you dive a little deeper into the cybersecurity aspects?
Yeah, I'm not a Luddite, but I'm not an early adopter because I'm worried about the security side of things. And I should say there's two levels of security. We do classified programs. That's totally separate, different. I'm sure there's a whole bunch of IT professionals listening to this that work in that area. That's a totally different setup. I won't touch that because I don't really want to talk about it. But even on just the normal company security of our IP, of our intellectual property, of course, but also our secret sauces, our ways of doing things that we never even bothered to patent because we don't want. All the patent does is give you a license to sue, right? We've seen this whole evolution. I started this company 30 years ago, and of course, the internet was barely started then. I was still, doing Space bulletin boards. Web pages didn't exist, and we've seen this evolution of. We didn't really have to worry too much. For one thing, we started the company on Macintoshes. I will say that because my wife worked for Apple, and it was just as cheap for me to get a Mac, and we didn't have a security problem at all. It's only when we went over to Windows. But what we've seen is that the nefarious actors around the world, and we do defense work, we do high tech stuff. They were really attacking the big boys. It was the Boeings and Lockheeds or the other big companies that were getting attacked. But they quickly learned, built up their security. And what happened is they turned and looked at us mid tier. They saw us as the weak link. Luckily, in Paragon's case, because of my background with computers and having been programmed and actually going to Stanford to get a computer degree in the beginning, we found that they were really going after us. Paragon, though, has always kept as much as we can inside of our firewall. Now that we're in the cloud, I don't trust the cloud. We have been forced to the cloud in some things, but you never know where the cloud's going to go. I mean, heck, for my security clearances, I know I've gotten notices from the Defense Department saying the Chinese just hacked our place and now have all your data. We've always tried to avoid that. And the only real way to avoid that is to have complete control over what's behind your firewall and the access to it through that firewall. And that's how we've dealt with it. Really, I have, 200 terabits of storage, medium, stuff like that. We just can't trust it to be out on the web. If it's out on the web, if it's even in the cloud, it's dollars to donuts. It's in somebody's hands you don't want to have.
So some of the projects that you've got going on, you mentioned earlier, are in our pre-podcast conversation about Halo, new project that you've got out there. Can you tell us a little bit about that one?
Yeah, Halo is part of what NASA calls the Artemis project, which is the Back to the Moon initiative. And Halo itself is meant as a weighed station that's in a very interesting eccentric orbit. It's known as a Halo orbit, but Halo also stands for high altitude, low orbit, something or other. After a little while, you forget what the acronyms mean. But it's really, think of the ISS space station that's going around Earth. It's that, except you put it around the moon. So it's smaller, but it's got all the same capability. You can dock spacecraft to it. You can live there for a little while you stage your expedition to the moon. You come back up from the moon, dock, and do things, and then go back to Earth. So it's sort of a way station. So we're doing all the life support for that, everything but the pressure control system. The pressure control is done by the spacecraft owner. And that's everything I've said. We keep them right at the right temperature. We keep the air, and they exercise. So we've got to pull the moisture out of the air and all that stuff. Everything you need to keep humans productive and satisfied and comfortable enough to do their job. It's pretty hard because you're outside of the Van Allen radiation belts. So we got a much higher radiation environment than the space station. Space station hardware was designed in the 1990s and built in the late 1990s. A lot of it is obsolete just from a parts standpoint. You can't find the resistors you had back then. And then, of course, with the radiation hardening, you need these high rad hard parts that are expensive. A capacitor, which you could maybe buy at a Fry's Electronics or an electronics store for $50. They cost us $2,000 because they're extra packaged, they're radiation hardened, they're extra tested. So it's a tough environment, but it's an exciting piece of work. Not many people can say they're building a house for going around the moon.
Yeah, absolutely. Yeah. So, so obviously you've got a lot of very talented folks on your team, and you all are doing some outstanding work. Can you kind of share with us a little bit of the principles that you've used to put together that team, and even get folks to join you? I mean, I got to think that might be a challenge, getting the right talent pool in place.
Yeah, all of those things are talent. Finding the right talent, motivating correctly, getting them on task, and getting the job done is really what it comes down to. And we have different parts to do that. Now, to achieve that, one of the things we've got going for us is space is cool. We're not asking somebody to sit in a cubicle and run numbers all day, although some of our analysts do a lot of that. But the ultimate product is really cool. Not a lot of people, like I said, can say, "Hey, I'm building the life support for system for going around the moon," or I'm going down to Florida to watch the launch of the next water processor we're putting up on space station. So there's a cool factor, but that only does it so far. There's other cool space companies that can attract people. The next one is another reason why I started this company. I came out of large corporate America. I won't say where, but there were let's say, maladies associated with large corporate America, as far as treating people like numbers as opposed to people. You hear people are our greatest asset, but they don't necessarily, walk the walk or talk the talk. We've always tried to give a very collaborative, fun environment. In fact, one of our sayings is, if you're not having fun, you're doing something wrong. Um, but that also means that you're achieving something. One of the things that motivates humans are dignity and belonging. And one of the reasons I started this company, I felt the corporate America kind of denigrated that dignity. But the belonging is not only to things bigger, it's things bigger than yourself. So it's not just you, but it's your community, your family, your church, whatever. But one of the things is you're working on something that you're proud of, and you belong to a team that's achieving something. So making that work in an environment, in a collaborative environment, is it's fun to me. It's really what makes things go. There's nothing greater than when I see one of our teams achieve something. There's a certain amount of Paragon pride, but I really feel that we're doing the right thing. The people feel good about what they're doing. So that's good about the space work. You ask anybody what they might admire most about America, in the top 3 will be the space program. So we're doing something that's not only bigger than us from a standpoint of the country and everything, but the world and humanity in general. So that really is interesting to people. But so then the other thing was, though, keeping the talent. Definitely what I've seen over the years is there was only one game in town, really. In the United States, it was you were going to work on a NASA program, or there's shuttle or space station. And in the last 30 years, we've been in the present of creation of many things. Elon came to us with his his PayPal money, wanted to put something on Mars, and then found out he couldn't launch it. So we actually were there with the start of SpaceX, and all the way up. The Dragon vehicle is the architecture of the life support system is ours. So we worked with him for 10 years on that. Boeing's new commercial venture. So that's what's really changed. Is it's no longer just one customer, but that also means there's commercial companies, some of them with more money than God, who are willing to try to bring in and hire your people away to do the stuff in-house. And there's a certain desire to be vertically integrated. And so that's something that's a business concern. At the same time, I'm a very much long-term thinker. I wouldn't have started this space company in 1993 if I wasn't. And I know that no engineering company for complex systems that wants to be vertically integrated will last past the 3rd generation of that system, because eventually the best systems integrators, the best one that can get the best of the world and put it together, is going to end up with a better product than somebody tries to do it all themselves. But now that may be for some of my competitors down the road. But I'll say, when I started this company, my chief competitors were billion-dollar corporations, and my P&L even today is a rounding error on their P&L, but I still beat them. It's a matter of focus, giving exciting work, having people that are really enthused about what they're doing, and very smart people.
Yeah. So, wow, it's amazing how much of that rings true to what we see in the IT realm as well. So, making sure that you have good work that's interesting and pushes their thought processes and that they can be proud of when they're done. Well, that's a big deal. So I get that. And you mentioned you started diving a little bit into the commercialization of the aerospace industry. So that has to have been a huge change. How does that affect the industry going forward, and what challenges do you see, and especially how can technology help in meeting those challenges?
Well, where we've seen probably the most effect is, when the government was the only thing in town, everything was custom made for the government. And the commercial world doesn't want that. They don't want to pay all the upfront cost to have a custom made thing for themselves. So we've actually developed something called Common Eclipse, which is everybody needs a humidity control system. Now, there may be 2 or 3 different types, depending, again, on the length of the mission, the number of people you have on the spacecraft. but they're really looking for a more turnkey solution. The commercial world, they don't. In fact, they'll say to us, okay, we need it to fit here. How much will it cost? Okay, if we just use one of your serial number 2 out of something you already built for something else, what does that look like? And they actually will seriously look to see if they can use what's already there. So there is, like in the maturing of any industry, same with aircraft and stuff, there's a certain uniformity that's being imposed by the economics of development and time to market. You can have a custom system, but it might take us 7 years and $150 million, or you can buy something we already have and we'll have it up there in 2.5 years and it'll cost you a third of the price. And each business model has to determine if what's important to them. So luckily, we've always worked commercial and government all our lives from the beginning in 1993. I've seen some maladaptions of those people that are only been government or at least the division of there's large corporations that only do government. Trying to adapt to that mindset is very tough for them. And so being adaptable there. And then the other thing is the government very much was, we want these requirements. What? You're not meeting that requirement? Well, how much more will it cost? Commercial world is, well, we like these requirements, but tell us what really costs a lot of money. And there's much more negotiation on where the requirements and why they're there. We have one that just came up about, the corner of the box that I talked about, high humidity, high temperature. We want to have 4 astronauts exercising all at the same time, and your system has to be able to handle that much water in the air. Well, it's like, great, but if you just put 2 exercising and then a lunch break and then 2, we would get rid of all of that. We wouldn't have to do the analysis. We know the system will do it. The commercial world will say, okay, that's what we'll do. We call it an operational restriction. Okay, we won't have our cake and eat it too. We'll make this little restriction to make it cheaper and faster for us. The government doesn't necessarily do that. And that's one thing that definitely has changed. It was what Elon was extremely good at, of just looking NASA in the eye and say, exactly what value does that bring and exactly why do you want that? And he got them to back her down a lot. And because the ultimate thing of these commercial contracts is, we want you to transport people to space, or we want this data back from the moon. They're not allowed to say how they got it. They're not literally allowed to dictate every little piece of it. So that's what's changing in the industry. It's good for us because we're big systems thinkers. We know how everything we do affects every other part of the spacecraft. And we can tell somebody, you impose that on me, and here's all the things it'll do to you downstream, operationally, everything else. So there's much more negotiations there. And being a small, agile company that understands why we do things, not just that we do things, is really why we've been beating our competitors.
Yeah. Wow. So sounds like, a lot of reusability and economy of scale coming into play there.
Economy of scale is still 20 of something instead of 2 of something, but yes, it's economy of scale.
Well, but at that level, if you're, especially that repeatability factor, right? That sounds like that would be a huge cost savings. Wow. Well, so what do you see about when you look into the future a little bit? What new technologies are coming forth? How do you see that changing the game? Just kind of, just what have been your thoughts on that about trying to plan for the future? You said you're a long-term thinker, so I'm gonna pull that string here.
Yeah, and to give you an idea of long-term thinker, I just finished a chapter of a book that'll come out in February. I don't make any money on it, so this is not a plug, but it's actually a chapter on how to build a life support system to go to the next star. So that's the long-term thinking. And so I've done a fair amount of that, but I use elements of where we are now. Right now in life support and thermal control in extreme environments, we're in what we call the physiochemical stage. Everything is really machinery that will do this. You maybe have seen pictures of the farms on Mars and in spacecraft. In my chapter, I kind of poo-poo that a little bit. We see things though by the biological side of life support. how we provide foodstuffs, how we provide the basic building blocks for food is going to be, let's say, biologically engineered. Now, this is out there. This is two decades, 3-4 decades. I do say in that chapter that the life support system will look a lot more like a brewery than a factory right now, like it does now. A lot of vats of genetically engineered things that are producing oxygen, digesting materials, depending on how much you want to do. In the nearer term, what we see is the inevitable compromise of commercial. We have a saying that to make something complex is hard, to make something simple is harder in our industry. You can make this, I won't say Rube Goldberg is maybe the wrong idea, but you can generally engineer a fairly complex thing that's expensive, that is at the price point of a government customer and stuff. When you start getting the commercial pressures, you learn how to do things more simply. You question yourself more. Again, it's a little bit of not hitting those corners of the boxes. So I see humidity control, for example. We have 3 different technologies: membrane-based technologies, which have no moving parts. That's up on the space station right now working. It's closed the loop to 98%, so we recover 98% of the water all produced on station by urine and wastewater and stuff. Those types of technologies, but how do we capture the water out of the air, how we store it, how we clean it for potability so you can drink it. All those technologies are going towards low moving parts, filter-based systems that don't clog up and don't require high amounts of maintenance. All things that are very precious in orbit. You can always have a Roto-Rooter come out for your waste pipe out of your house. Right. You can't do that on station.
So if you call Roto-Rooter, they're not going to show up, huh?
Yeah. Thermal control is the other one I see a lot of technology advances. Of course, 3D printing has changed a lot. It used to be one of the big companies in my industry had a lock on it because they had a lock on the brazing technology to put them together. 3D printing has allowed us to get around that. So much more custom and much more adapted to the exact problem that's going on there. That's nice. And then finally, I guess to say is the introduction of the information side of it is going to change a lot. One of the things I'm actually traveling to LA on Saturday for a top level meeting on space medicine and the monitoring of the human body. Right now, during launch, you have heart monitors on and stuff, and they've stuck catheters up people in orbit. They've taken tissue samples out of their thighs. What we have to do is make that less invasive, but everything you touch in the life support system actually is also monitoring you to make sure the life support system is doing its job. So no pee shall go unsampled. No feces can go unsampled. Your sweat, your bodily functions. So I'm seeing that much more incorporated. The new little technologies, the skin patches and stuff that tell you how the human is doing. We're excited about that because our feedback in the past has been, depending on how crotchety the astronaut was, I liked it or I hated it. We need a little more quantitative data than that.
Right.
Yeah. Did your eye pressure
how many
go up?
Stars do you give it?
Excuse me?
I said, how many stars are they going to give that particular ride, that astronaut? Yeah, right.
Yeah, well, we have a saying in Paragon prides itself, Paragon's name, it's what you measure other things against, right? That's what Paragon means, the paragon of whatever. And so one of our sayings is to our commercial customers is nobody wants to be in the second best life support system.
Oh, yeah. That makes a lot of sense to me. Well, hey, Grant, we really appreciate you taking the time to get on with us today. Really enjoyed the visit. And why don't you tell our audience how they can stay in touch with you? I know a lot of them are going to be interested in following what you're doing and Paragon's doing there as after they've seen this podcast for sure.
Sure. We have a presence on all the major social media networks: Facebook, Instagram. We do not do TikTok for security reasons, talking about cybersecurity. But our name is a variation of Paragon SDC. So SDC as in Space Development Corporation. So Instagram is paragonsdc.com. LinkedIn has one there. The best is to get on those social medias, sign up for automatic, for following us. We tend to put out a fair amount of stuff on those, things we're doing, things that we've achieved. And then also on our website at paragonscc.com, we have links to other places you can go get more information, following NASA TV or whatever else. It's fairly easy to follow us. We encourage you to do so, because you never know what new exciting thing we're going to be announcing.
Oh, I'm sure. Yeah, I look forward to following you myself. Listen, be sure to subscribe to this YouTube channel. Like us as well so the word can get out. We've got a lot of new content coming with some great guests like Grant here. So be sure and do that. Grant, again, thanks for your time. Appreciate it. Have a great week.